Flutterby, butterfly, on velvety wings in the warm summer sky.
And you are of course most welcome. Today we are looking at Project Euler problem number 36, double base palindromes. The decimal number 585 is 10010010001 binary and is palindromic in both bases. Find the sum of all numbers less than a million which are palindromic in base 10 and base 2. And please note that the palindromic number in either case may not include leading zeros. It's actually very important, this last bit. So, pretty easy problem, and there's not a lot. Oh, what's this? There's not really a lot to talk about here. There's a brute force solution and something a bit more elegant. But it doesn't really deserve much of a deep dive because it's a very simple problem. So, first thing I'm going to do is import time. And then we'll look at the brute force case first, which is just go through every number between 1 and a million and total up the ones that are palindromic in both bases. Now, Python provides a very useful little function for this. So let's say I want to make a function that turns our decimal number into a binary number. So is binary palindrome. So it takes in a number, then it simply does this. N equals binary I, and then we'll just print n. So this bin function takes the decimal number and turns it into binary. Really useful stuff. So I could have written out my own function that converts decimal to binary, but no point reinventing the wheel. It's there, might as well use it. So def p36 brute. I'll just show you first what the bin function actually outputs, so that the next bit will make a bit more sense. For I in range, and we'll do up to, let's say, 50 just for illustrative purposes. 0 to 50, and then we simply what I should do, this should be a return actually, so I'll do return n and then print is binary palindrome I. Okay, so we'll just run this and I'll show you the output. And I haven't called the function. That's stupid, isn't it? Well, there we go. Right, let's try that. There we go, and we can see that it prints off all the binary numbers 1, 1, 0, 1, 1, etc, etc. But if I make this a bit bigger so you can see, it won't let me go any bigger. That's fantastic. That's really helpful. Okay, so we've got 0b0, so it actually outputs a string, but it has this 0b before the actual binary number. So what we need to do is shave off these first two characters. So that would be n n2, something like this. Then we should just get the binary number on its own, and then we can test if it's palindromic. So what we're going to do is return n2 is equal to n2 and then reversed, which is this, colon colon minus 1. So this should return whether the number is palindromic, like this. So we've got a few trues and a few falses. So I'm going to say that works. Now another thing to note here is that only odd numbers can be palindromic in binary. So let's say we've got the number 4 in binary, which is this, that's 100. The only way to make this palindromic would be to put 2 leading zeros there, but the problem specification clearly states that leading zeros are not allowed, so this would not be valid. 5 is valid because it's palindromic. So if the rightmost digit is 0, you need the leftmost digit to be 0 as well, but that's not a valid answer. So the rightmost digit must always be 1, which means that the odd numbers only are valid palindromes. So let's do the brute force solution. It's fairly quick. 0 to 10 to the 6. So we need to check if the decimal number is a palindrome, and then we need to check if it's a binary palindrome. So if string I is equal to string I reversed and is binary palindrome I, then total plus equals I. There we go. And then right at the end we return the total. So let's go for a print and see what that does. We also want the time, so start equals time, and in here time minus start, and I think we are ready to go. That produces the correct answer in just under a second. So we've just gone through every number between 1 and a million, well 0 and a million, and checked if they're palindromic in both bases. Obviously we can speed this up by just going through the odd numbers, something like this. So starting at 1, it should save a little bit of time. Yeah, that's halved it basically, so yeah, there we are. But there is a much quicker way. So instead of looping through all the numbers, why don't we only generate palindromes? There is a way to do this. So let's move this down here, and we'll declare a new function called def p36 dynamic, and it's going to work a little something like this. Total equals 0, and then we're going to have a bit of loops. So for I in range, so here's what we're going to do. I might as well finish this. We'll start at 1 and then go up to 1,000. What we're going to do is this. Let's say we have the number 12. We are then going to reverse it and then stick it on the end, creating the number 1221. And then we do the same for 13. So 13, reverse it, stick it on the end, 1331. Then the next one, 1441. Now this is okay for the numbers with even digits, but of course there are lots of palindromes with odd digits as well. So for each of these we're going to add a digit in the middle as well. So 12121, 12221, 12321, 12421, etc, etc, and then with this one 13131, etc. So this is the algorithm that I have come up with. It's a bit finicky, it's not my favourite algorithm, but it does work. So we're going to need to get the palindrome up. So n equals str I plus str I reversed. So what we're doing here is just basically what I just said. We're taking a number, we're reversing it, and then we're sticking the reverse of the number on the end to create a new palindromic number. I hope that makes sense. Then we're going to test, because we know this is a palindrome, so we don't need to test that, but we need to test if it's a binary palindrome. So if is binary palindrome, we're going to use n, but we need to convert it back into an integer, so int n. Then we add to the total. Total plus equals int n. But then we need to add the middle digit. So we're going to have another loop right here, but we're only going to do this if the number is small enough. We don't want any 7-digit numbers, so if the number already has 6 digits, we're not going to add the middle number. So if length of n is less than 6, then we're going to do this. For j in range 1 to 10, so we make sure we get all the digits, and then n equals string I plus string j plus string I reversed. So that's creates the palindrome with the extra digit in the middle. Then we test it again for palindromicity. I don't know, is that a word? So that goes there and that goes there. As I said, this is pretty ugly code, but I couldn't think of a better way to do this. And then after all that, we return the total. There we go. So if we run this, it should be a fair bit quicker. So I'm going to copy this. And let's put dynamic in here. Right, let's see if this works. I don't think it'll produce the right answer, and I'll explain why in a moment. No, it's the wrong answer. It is a heck of a lot quicker. It's 4/100ths of a second. So the reason it's not producing the correct answer is because we haven't counted the 1-digit palindromes. So 3, which in binary is 101, that's a palindrome. We should be counting that. 7 is oh gosh, well, 1 certainly is. 3 is 101. I think 7 isn't, because that would be 1101. That's not a palindrome. 9 is 8001. That's a palindrome. Hang on, is that correct? I'm getting all confused now. 5, I'm getting terribly confused now. So 1 is 1, 3 is 11, that's a palindrome. 5 is 101, that's a palindrome. 7 is 1101, that's not a palindrome. And 9 is 100. Fuck it. Do you know what? I'll just do a fucking list comprehension. Right. I was going to hard code it, but I've confused myself. Right, we're going to do this. So it's going to be sum of I for I in range. Could do 1 up to 10. If is binary palindrome I. Sod it, we'll just do that. Should produce the correct answer. Boom, there it is. Right, so that is it. 4/100ths of a second. That's a quicker algorithm, and that's pretty much all I've got for today. Not a very interesting problem, not a very interesting solution. So thank you very much for watching, and I'll see you next time.
Flutter by, butterfly, On velvety wings in the warm summer sky, flutter by, butterfly. On velvety wings in the warm summer sky.